Now that you've graphed a basic sine of x graph, I want to go ahead and graph cosine of x in the same way. So you've got another xy table here, where in this case my f of x function is the cosine of x. So again, refer to your unit circle, look at all of those x coordinates that correspond with these different angles, and fill in the following table. So when x is 0, the cosine of 0 is 1. Again, that's the x coordinate at my 0 pi angle. At pi over 6, the cosine of pi over 6 is root 3 over 2, which again, I'm approximating all of these so that I can plot them on my graph a little bit easier. The cosine of pi over 4 is root 2 over 2, which is about 0.71. The cosine of pi over 3 is 1/2. The cosine of pi over 2 is 0. The cosine of 2 pi over 3 is negative 1/2. The cosine of 3 pi over 4 is negative root 2 over 2, which is about negative 0.71. The cosine of 5 pi over 6 is negative root 3 over 2, which is about negative 0.87. And the cosine of pi is a negative 1. Continuing in our second column, the cosine of 7 pi over 6 is negative root 3 over 2, which again is negative 0.87. The cosine of 5 pi over 4 is root 2 over 2, which is about negative 0.71. The cosine of 4 pi over 3 is negative 1/2. The cosine of 3 pi over 2 is 0. The cosine of 5 pi over 3 is 1/2. The cosine of 7 pi over 4 is root 2 over 2, approximately 0.71. And the cosine of 11 pi over 6, root 3 over 2, about 0.87. Last one, cosine of 2 pi is just 1. Let's go ahead and plot those. Again, our x-axis is divided the same way our sine graph was. The longest, or the last point I'm going to plot is 2 pi. Cut that in half, we get 1 pi. Cut that in half, we get pi over 2. And in between 1 and 2 is a 3 pi over 2. In between pi over 2 is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then I know I'm going to graph my pi over 6 and pi over 3. And again, I'm just going to show tick marks for those other 2 points that I'm going to plot. So here we go. To start us off with cosine, the highest y value that we ever will get out is a positive 1, and the lowest is a negative 1, the same as sine. So the cosine of 0 does not start in the center this time. The cosine of 0 is actually a positive 1. So I'm going to start all the way up at positive 1 on my y-axis. Continuing down, the cosine of pi over 6 is about 0.87. I'm going to draw on my 1/2 marks to help us. The cosine of pi over 4 is about 0.71. The cosine of pi over 3 is 1/2, and the cosine of pi over 2 is down at 0. Continue graphing this function. Pause your video, plot all your points, and then press play to compare. So you should have these points plotted on your graph. Go ahead and connect them. They should form another wave similar to your sine graph, except it starts up at 1, so it looks slightly different. It's still going to continue in that same way to form another arc or a wave sort of going up and down the same exact way your sine graph looks. Again, that starting point is just slightly different than our sine graph. Again, I want to fill in these values to the left. So the period for my sine graph, it starts to repeat itself right here at 2 pi, where I've drawn in those dotted lines. So my period for this graph is the same as a sine graph. It has only gone from 0 to 2 pi before the wave started over again. So my period is just 2 pi. My amplitude, the distance from the middle of my graph up to the highest point, middle of my graph down to the lowest point, is the same from the middle to the highest. I can continue measuring that distance that amplitude is a positive 1 every single time. Again, it's always positive. My domain, same as the sine of x, is all real numbers. And my range, again, the same as sine of x, goes from a negative 1 to a positive 1. With brackets, I'm including both of those values. So now that you know what the basic sine and cosine graphs look like, we're going to go ahead and change just one thing about this graph. So looking to your next page of notes, we're going to change the amplitude. And again, the amplitude is that distance from the middle of your wave to the highest and to the lowest points on your graph. To start off, I want to first plot just basic sine of x. This is my sine parent graph. Fill in your critical values on the left here, so a basic sine of x. And I'm going to graph mine in the black pen. I suggest you do yours in a black pen or pencil, and then we're going to do different colors for the other three graphs so we can see the differences. At 0, sine of 0 is just 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, sine of 2 pi is back to 0. Those are your critical values. Those are the 5 points you plot every time. So go ahead and let's plot those. So down here we've got our big nice graph to start us off. We're going all the way to 2 pi. Divide up your x-axis first. Cut that in half, we get pi. Cut it in half again, we get pi over 2. Add that 3 pi over 2 value, and I'm always starting at 0. The highest point is marked for you as a 3, so go ahead and divide that into 1, 2, 3, and go down negative 1, negative 2. Lowest will go as a negative 3. So if I want to graph basic sine, always start at 0, 0. At pi over 2, I'm up at 1. Pi, I'm back to 0. 3 pi over 2, I'm down at a negative 1. 2 pi, I'm back to 0. That's your sine of x graph. Go ahead and connect, making sure to curve and not point your graph. And now switch to a different color. I'm going to use blue, and we're going to go ahead and graph the second picture. 3 sine of x. The only thing that changed is that there is now a 3 in front of sine. So I'm still going to find the sine of 0, the sine of pi over 2, the sine of pi, except I want to multiply each of those values by 3. So I can refer to my original parent graph, my sine of x table, and just take all of my outputs, multiply it by 3. 0 times 3 is just 0. 1 times 3 is 3. 0 times 3 is 0. Negative 1 times 3 is negative 3. 0 times 3, again, is just 0. Now go ahead and graph this function, 3 sine of x. So I'm still starting at 0, 0, except this time at pi over 2, I'm not at 1. I'm all the way up at the top at 3 here. Pi, I'm back down to 0. 3 pi over 2, I'm down at a negative 3. 2 pi, I'm back at 0. So those x-intercepts have not changed. Connect, and notice what has happened when I put in a positive 3. That graph has grown vertically. It has stretched out. It is much taller. It's much skinnier. And that amplitude has now changed to a 3. Let's see what happens in our next graph. Negative 2 sine of x. So now two things are different. I'm going to graph this one in red. There's a negative sign in front, and there's a 2 in front. Refer back to your parent graph. Multiply all those y values by a negative 2. We get 0, negative 2, 0, positive 2, 0. Go ahead and graph this function, negative 2 sine of x. Starting at 0, 0. Pi over 2, we're down at negative 2. Pi is back at 0. 3 pi over 2, we're at a positive 2. And 2 pi, we're back at 0. Go ahead and connect. And there's my next graph. Two things have changed. The amplitude is now 2, and it has switched direction. Instead of going up to the right, or up to my positive y values first, it's going down to the negative values. It has reflected across the x-axis. And lastly, we have 0.5 sine of x. I'm going to graph this one in green. Take all your y values, multiply them by 0.5, so now I have 0, 0.5, 0, negative 0.5, and 0. Go ahead and graph this function. We're not going nearly as high as the other graphs have. I'm still starting at 0, 0. Pi over 2, we're only at 1/2. Pi, I'm back at 0. 3 pi over 2, I'm at negative 1/2. And then back to 0. Go ahead and connect. And there's my graph of 0.5 sine of x. So now that we have all three of those graphed, let's make some conclusions on what we can do to change the amplitude. At the bottom here, in summary, to change the amplitude, all I need to do is change the a value in front of my trig function. And a couple different things happened when I changed that a value. So here's that a value, f of x equals a sine of x. Throw in a different number there, your graph's going to look slightly different. The larger the a value you plug in, the larger your amplitude is. So a larger a value will give me a taller graph. It is vertically stretched. And in turn, that creates a larger a value, a larger amplitude. If I have a smaller a value, like in our last example, well, this is going to shrink my graph. This will make it shorter. And we call this vertically shrinking our graph. Now the last thing that we did was the one in the middle. Not only did our amplitude change to 2, but there was a negative sign in front of this. So what did that negative sign do? Well, it reflected the graph across the x-axis. So if you ever throw a negative sign in front of your function, you're going to reflect. So again, to look back up at our three different graphs here, my blue graph still has a period of 2 pi. It still has a domain of all real numbers. The only two things that changed about this blue graph, my 3 sine of x, is that my amplitude is 2, and my range has also changed. My range has now gone from a -3 to a +3. My red graph, domain is still all real, period is still 2 pi. My amplitude changed to 2, and my range changed from -2 to +2. You always start with a lower number and end with a higher number. Also, don't go from 2 to -2, start from the bottom, go from -2 to +2. And my green graph, again, domain is still all reals, period is 2 pi. The amplitude is a 0.5. The range goes from -0.5 to +0.5, again with brackets. Also notice the amplitude on my red graph is a +2. Always represent your amplitude as a positive number. I'm going to move on to just one quick example where an amplitude has changed. F of x equals -3 sine of x. Again, we're not going to draw a table of values every single time, but you do want to think about where those critical values fall. I'm going to go all the way to a 2 pi, cut that in half on that pi, cut it in half, pi over 2, add 3 pi over 2, and I always start at 0. I notice that there's a 3 in front of here. That means my amplitude is going to be a 3, so the highest value should be a 3. The lowest value is a -3. To start graphing this, you want to think about what a sine graph looks like. Well, a sine graph will always start at 0, 0. Since it is a negative, I need to reflect. So a basic sine graph will always head up first in the positive y direction. A negative sine graph is going to go down. My next value will then be at pi over 2. I'm down at a -3. After you go up or down, you always come back to the x-axis, to that 0. 3 pi over 2, I'm up at 3. And 2 pi, I'm back down to 0. Go ahead and connect. And that's my graph. You can connect. You can show that it continues with arrows if you choose to do so, but you only have to graph one period. That period is 2 pi. Your amplitude is 3. Domain is all reals. And your range is -3 to 3. The last thing I want to mention is on example 5 and example 6, those should be cosine graphs, not sine